Let's try again, everybody. Um, let's work on this problem. Let's work on this problem. If you would like to know which tools am I using, I'm using PowerPoint. Yeah, just PowerPoint and a pen tablet, and that's it. Okay, now I want I want to firstly show you this. The diagram below shows the point P. The diagram below shows the point P. This is also my first time solving this. Let me use black now. Let me use black. I've been using green. Okay. The diagram below shows the point P and the point Q. Here are the coordinates. I'm not going to read them. This 0 is to 2, 4 is to 0. Point A is the midpoint. Point A is the midpoint. That is, we're going to use the midpoint formula immediately. They tell us that. Just know that, okay, I will have to calculate the coordinates of A, and I will have to use the midpoint formula. And I will have to use the midpoint formula. And because of this 90 degrees here, if you can look, there is a 90-degree angle here. This means that these two lines are perpendicular to each other, and we might be um, we might be asked to find the gradient of this line as well as the one of this line. But let's keep reading the statement. The line AB is perpendicular to PQ and intersects the x-axis. These are the x-axis here. Intersect the x-axis at G, at this point G, meaning this is the x-intercept, meaning y is 0 here. Okay, quickly now let's get to the point athi amaXhosa siqondene ngqo apho kufela ithole. Show that the gradient of PQ is equal to -1/2. Quickly, MPQ is equal to YP minus YQ over XP minus XQ. This is the formula for the gradient. So YP is 2 minus YQ is 0 over XP is 0 minus 4. So 2 minus 0, that's 2, 0 minus 4, that's -4, of which is equal to -1/2. You can punch your calculator as well. So we are done showing that. Let me clean it up now. I'm done with this one. It's just a 1 mark. It's just a 1 mark and it deserves it. This is so easy. Determine the coordinates of A. Remember, I told you that we will have to use the midpoint formula. So A is equal to xp plus x. Let me fix my writing. So A, the coordinates of A are xp plus xq, all divided by 2 is 2, yp plus yq, all divided by 2, which is equal to xp is the same as 0 plus xq is the same as 4, all divided by 2 is 2, yp is the same as 2 plus yq is the same as 0 over 2, which is equal to 0 plus 4, that's 4, 4 divided by 2, that's 2, is 2, 2 plus 0, that's 2, divided by 2, that's 1, so the coordinates of this are 2 is to 1. So this is your final answer. What I like about analytical geometry is that you are able to mark your own self. You are able to mark your own self Okay, let's go down. Determine the equation of the line AB. This is the line AB. They want us to determine the equation of this line. Oh my god, we don't have the coordinates of B. Remember, this is the equation of a straight line, y equal to mx plus c. So we need to know the y-intercept of this line. In fact, we need to know the gradient. We need to have any point that lies on this line, and yes, we do have that point, but we don't know the y-intercept. So we need to find the y-intercept or the gradient and the gradient. But because this line, remember this, I'm not sure whether I have told you guys this law. Yeah, on the videos above, there's a video that I've made that's its title is um its title is gradient properties. Visit the video gradient properties, or click on the link. Just click on the link here on the top right corner, then you will find this video I'm talking about, routine gradient properties. Then you will see all those properties of gradient. So if you have lines that are perpendicular to each other, so that means, let me erase these lines first. That means the product of their gradients is equal to -1. The product of their gradients is equal to -1. So MAB times MPQ or QP is equal to -1. We have already found the gradient of PQ. We have already found the gradient of PQ. The gradient of PQ is -1/2. So let me substitute -1/2 equal to -1. Why? Then please do reason for this. Don't just write this down. You have to reason that AB is perpendicular to QP or PQ. It really doesn't matter in maths. So times MAB. Then now dividing by 1/2 on both sides, we get MAB equals to +2. We get this. So the gradient of this line is equal to +2. Now solving the problem, y is equal to MAB x plus c. In the place of y, I'll substitute this 2 equals to the gradient, which is 2 also, the gradient, which is 2, times when y is 2x. Oh my god, I made a mistake. I hope you guys have noticed I have made a mistake. I hope you noticed when this is y and this is x. These are careless mistakes that we usually do. So y is equal to 1 equal to m is +2. This is our m is +2. X is this +2 as well, plus c. 2 times 2, that's 4, plus c equal to 1. Now take this 4 to the other side, then you will find out that c is equal to -3. And yes, here the y-axis are negative, therefore the equation of this line is equal to 2x minus 3. I prefer this way of finding the equation of a line, but let me also do the alternative way. Let me also do the alternative way quickly. I don't really like this way of finding the equation. Y minus y1 is equal to m into x minus x1. So y minus y1 is this one here, into 1 equal to m is this 2 we have already found, m or gradient. Then x minus x1, when y is 1, then x is 2. So here I would have my 2. So 2 times x is 2x. 2 times negative 2 is negative 4. Y minus 1. Then now we are solving for y. Y is equal to 2x minus 4. Take this to the other side, then it changes the sign, plus 1. So we get y equal to 2x, negative 4 plus 1, that's negative 3. This is the same as this. And thank you very much. Let me quickly jump to the next problem. Based on our equation, the coordinates of B are 0 is to negative 3. The coordinates of B are 0 is to negative 3. So calculate the equation. Calculate the length of BQ. Where is BQ? BQ, the length of BQ. Remember, if you don't know how to calculate the length, please visit my very first video of analytical geometry on this grade 11 playlist. You will see it on the end of this video. But the length, sometimes they can say the distance between the 2 points, or they just say the length. So this is how you do it. PQ is equal to the square root of xq minus xb squared plus yq minus yb squared. Forgive me about my writing, it's something that I cannot change. PQ is equal to, listen more to what I'm saying in words than what I'm writing down if you fail to see this writing. So xq is the same as 4 minus, then xb is 0 squared plus yq is the same as 0 minus, then yb is the same as negative 3. So use the bracket, say minus into minus 3, then you square that. So BQ is equal to 4 minus 0, that's 4 squared, that's 16, plus the negative times a negative times a negative, it's a positive. So 0 plus 3, that's 3. 3 squared, that's 9. So 16 plus 9, that's 25. So the length of BQ is equal to square root 25. So the length of BQ is equal to just 5. BQ, this is BQ. So the length, this length is equal to 5. This length is equal to 5 units. Don't forget to write these units here. Okay, show that this triangle above is an isosceles triangle. Show that this triangle above is an isosceles triangle. We need to remember or recall the properties of triangles. So if this triangle here, if this side is equal to this side but not equal to this side, then this triangle is an isosceles triangle. So for a triangle to be an isosceles triangle, then at least two of, I mean, if a in order for a triangle to be an isosceles triangle, then two of its sides should be equal. Just I take the at least that I've set back. It's not at least, it's a must. It's a must. Let me erase this part. I'll just keep the final answer. This one. I'll just keep the final answer, that one. Since I already know the length of this side, let me just find the length of this side. I assume that these two sides has to be equal. So from here to here it's 2 units. From here to here is 3 units. 2 plus 3 is equals to 5. And therefore this is an isosceles triangle. I'm done. Like, I've already found the answer, but let's work it out. You will see where did I get this. Okay, we need to show the calculations. So let's calculate this length. The length BP is equal to this xp minus xb squared plus yp minus yb squared. Let me do this. So BP is equal to the square root of xp. Xp is equal to 0 minus xb is also 0 squared plus yp is 2 minus yb, it's into negative 3 squared. So BP is equal to, this is going to be 0, so it is equal to the square root of 2 plus 3. I mean, a negative times a negative, it's a positive, so I have 2 plus 3 squared. 2 plus 3 is the same as 5, so I have 20. I have 5 squared. Like, this and that goes out, then I have this 5 equals to BP units. So this here is also 5 units. But is this triangle an isosceles triangle or not? Well, I cannot claim that this triangle is an isosceles triangle or what, because I do know that these two opposite sides are both equal to 5 units. So if this side is also 5 units, then this is not an isosceles triangle. But if this side is not equal to 5, then I'll be able to conclude that this is an isosceles triangle. So let me find the length of this side as well. So the length of PQ is equal to, math is not hard. Math is not hard or difficult. Xp minus xq squared plus yp minus yq squared. PQ is equal to the square root of xp. This is my xp. Isn't there any way that I can do this? But let's not find ways now. It's not time for that. Xp is 0 minus, it's 0 minus xq, it's 4 squared plus yp, it's 2 minus yq, it's 0 squared. So pq, so I hope this is clear. 0 minus 4 squared, so this is the same as 16 plus 4. This is the same as 16 plus 4 because 2 minus 0, that's 2, 2 squared, that's 4. And 16 plus 4 is the same as 20, so this is root 20. P2 is equal to root 20 units, of which this can never be equal to 5. So therefore, show that, therefore, triangle BPQ is isosceles. Then we are done. Now they want us to show that, let me do this. Let me do like this. Yeah. Let me erase this part. Let me erase this guy. Then let me draw. So now they want to show, okay, if P B Q R is a rhombus, so that is this this R, they extend this shape. So if, in order for this to be a rhombus, then this R has to be a point somewhere there, such that this is straight, this is also straight. So this R has to be a point somewhere here, such that this line is parallel to this one and this line is equal to this line, and also these two are parallel to each other and they are both equal to each other. Now determine the coordinates of R, and if we construct this diagonal, let me use another color red for this part. Let me use another color red. I like this. If we construct this line, assuming that this is a straight line, like from here straight to there, my R, then this line has to be equal to this line, as this one is equal to this one. That's how the diagonals of a rhombus are like. So to find the coordinates of this R, remember we know the coordinates here are 2:1. So to find the coordinates of R, given that we know these coordinates, it's easy. We just have to know the properties of all of these shapes. So this is what you're gonna do. Say you go straight to the midpoint formula. This is the midpoint formula. X1 plus x2 over 2 is to y1 plus y2 over 2. Now take this part and write it separately. Say x, but here we're dealing with R and B. So xr plus xb over 2 is equal to xa, which is our midpoint, is equal to xa, our midpoint. So xa is equal to 2, equal to xr is the one we are looking for, plus xb is equal to 0 over 2. So cross multiplying, you get 4 equal to xr. So here you have 4 is 2. We don't know yet. Now let's take this part again and write it separately. Say ya is equal to yb plus yr, the order doesn't really matter, over 2. So in the place of ya, I'll substitute that 1 equal to yb, it's negative 3 plus yr is the one we are looking for, over 2. Cross multiply, then you get 2 equal to negative 3 plus yr. Take this 3 to the other side, you get 2 plus 3 equal to yr. Therefore, yr is equal to 5. Therefore, the coordinates of r are 4 is to 5. Then you are done. And thank you very much. I hope this video helps. Don't forget to subscribe.